Rabindo, Rabind, so hello, Aravind, can you hear me?
Yeah, I'm here.
So, do you have any kind of knowledge before it on statistics?
No, I don't. I mean,
Any?
it's been a long, long time, but I think we can assume none for now.
Okay, so can I consider as like no, so not even basics, right?
Yeah.
Okay, so let's go for make it black. It could be easy. Okay, okay, fine. Okay, let's talk about the new model. So the name of the module is it's a statistics, right? It's introduction to statistics and probability. So in this particular module, we would like to go for understood what exactly we require to become like a data scientist or data analytics in perspective of in perspective of statistics. Okay. So my first question will start with the statistics. So if we have any kind of information, if you know about it, can you please answer this question? What is statistics? Jagdish, Sainath, Ramalakshmi, and Arbindo, if you have any kind of knowledge or in your own words, can you please answer this particular question? This statistics usually we are going to be using in a real time every day in a daily lifetime also we are using. Okay, so what exactly you know about statistics in your words? Can you please explain me? If you don't know, please let me know. I don't know. So that is also answer. That is also one type of statistics. Okay.
It is a kind of analyzing and
Hmm.
the combination of max like
Okay.
that.
Okay. So basically, statistics will help you to, it can help you for analyzing purpose, right? Okay. So basically, what exactly the statistics or statisticians are doing, okay, based upon the problem statement. So you have a problem statement. So problem statement means it can be a problem which is given by the project manager or else client that we are calling it say a problem statement or business problem. Okay, business problem. Okay, so based upon the problem statement or business problem, as a statistician we need to providing the solution for that particular problem, right? For that one, what exactly we will do based upon that particular problem statement or business problem, the first thing is that we need to go for collecting the data. First, what you will do actually based upon the problem statement, we need to collecting the data actually. Once if you collect the data, then what you can do, we can able to go for analyze that particular data. Okay, analyze that particular data. Is it clear? So by the time of analysis, we can able to go for do two things. One is for descriptive analytics, and second one is prescriptive analytics. Okay, and we have one more thing is there. It could be, okay, predictive analytics. Is it clear? So when we are talking about statistics, based upon the problem statement, we need to collect the data, right? After you collecting the data, we need to go for analyze that particular data actually. By the time of analysis, we are going to be getting the three kind of analytics. The first one is the descriptive analytics, second one is prescriptive analytics, and third one is predictive analytics. Is it clear? So let's talk about what exactly the descriptive analytics, what exactly prescriptive analytics, what exactly predictive analytics. We'll talk about it. So for example, you have a data of 1 year, 1 year of stock value of one particular company. Okay, you have 1 year of I mean for example 2019 to 2022 till to date, whatever we have it. For example, it's a 3 years, right? You have a 3 years of data, you have it. Okay, what exactly this data? One company stock actually. Okay, so this is the data when we have it. Okay, so here we can able to go for give the description. Description means what? In this particular 3 years, in this particular 3 years, what is happening, what exactly happening, that we can able to talk in a two ways. One is in a summarization, so we can able to go for summary of that particular 3 years of data, whatever the data we have it. Okay, so that particular data we need to go for give the summary. This summary we can able to give the summary in a tabular format, or else we can able to give the summary in a graphical format. Okay, visualization or without visualization. This descriptive we can do with visualization or without visualization. Okay, so summary about or descriptive about your data with help of so no with visualization, without visualization. So what exactly this descriptive is doing, what exactly is happening in these 3 years, that overview, that explanation, we can able to get it, nothing too much about it. Okay, so now prescriptive analytics in the sense, after you understood this particular 3 years of analysis, okay, or after for this particular 3 years of data, after your analysis is done, then what we can do actually, we can give some kind of prescription. Maybe if you do this scenario in this particular time, maybe you can get the profit, okay, at this moment. Maybe if you do that, if you take that particular decision on that particular day, so you might be increase your sales, you might be increase your stock value, right? That kind of prescription we will get it based upon your past experience, or we can give you some kind of prescription about your historical data. Okay, so that exactly business intelligence are doing actually. Okay, business intelligence or data analytics are doing with this two areas, description and prescription, only these two things which is done by the data analytics. Now coming for the predictive analytics in the sense, with help of this particular 3 years of data, so what we can do, we can able to predict the next 2 years, what is happening in the next 2 years, that we can able to predict, that we are calling it a predictive analytics. I hope you got it, what exactly the difference between the descriptive, prescriptive and predictive. If you have any kind of doubt, please let me know. I just wait for 2 seconds or 1 minute of time. By the time, if you have any kind of question, I would like to answer it. Arbindo and Jagadish and
No,
Ram
sir.
Lakshmi and Sainath, you just try to use the time. So if you have any kind of questions, okay, you can please you can ask it. Definitely, I will answer your questions.
Clear, sir.
No questions.
Okay.
No doubt, sir.
Okay, now now we'll do a small example actually. Okay, we'll do a small example about statistics. Okay, so for example, what I want to do actually, I just want to do that. This is the problem: the average income of the average income. Okay, for the for the Indian citizen. Indian citizen. See, or Indian people. Okay. See, you have a GDP rate, right? For example, when you have you would like to go for find out the average income of one specific day of one particular person. Okay, so especially in India country. Okay, that particular situation, what you can do, you need to collect the data of your GDP information, right? So from that one, we would like to go for do some kind of analysis. What could be the population of that particular country, and what could be the GDP rate, and what is your yearly income of that particular entire country, and then we are dividing onto each and every person, right? Maybe one day he might be average income is this thing, right? So that kind of things we will do it actually. That's a small example for understanding that one. Okay, so here for that one, what exactly you will do, the average income for the sample drawn from that particular country or not. Okay, and both values are representing mean income, but one is a parameter and second one is a statistics. Okay, see, when I'm talking about this average income of Indian citizen, I got the two names. What are the names? One is the population, right? Okay, and second one is the sample. So here this is the average, okay, average income of the entire country, right? That means it's a population, right? Okay, so here also we'll talk about average only. Here also we are talking about mean part only. And in so if you want to do this particular thing, it's very tough, right? So that what we can do, we can take some kind of sample data, and from that particular sample data we can able to go for give mean value. So this is the sample which could be replica of your population. It could be, so both values are representing the average income of a person of that particular country. Okay, but one data is the sample data, one data is the population, right? Okay, so when we are talking about a population statistics, that kind of name we are calling it say parameter. Okay, that name we are calling it a parameter. When we are talking about statistics with respect to the population, that we are calling it a parameter. When we are talking about statistics with respect to the sample data, that we are calling it a statistic. It's not a statistic. Okay, when we are talking about statistics about the population data, the terminology we are calling it as statistics. When you're talking about statistics respect to the population, that we are calling it a parameter.
Why these names? I mean, this is confusing. I mean, parameters are generally the attributes of
Yes,
the
here
population.
statistics is also attribute. So parameter means here mean, right? So mean population is a parameter. Okay, for example, standard deviation of the population, it is also one object only, right? That is a parameter. For which parameter? It's a population parameter. Here the statistic is also same like a parameter, but here also mean of sample, mean of standard deviation, mean of variance of this variance of the variance of the sample, mean of sample, standard deviation of the sample. When we are talking about sample data, the terminology we are calling it's a statistic. Okay, so because of sometimes instead of using the sample data, okay, instead of using the population data, people can call it as a data, but the data is about statistic information. That means we are talking about a sample data. So they are talking about data, but they're not specifying like it's a population data, they're not specifying like a sample data. They're specifying the mean and standard deviation of the parameter, or parameters of parameters about so mean standard deviation. That means indirectly we need to understand it's a population. Okay, it's just a terminologies. Okay, so different areas we are going to be using the statistics. Okay, so all scientific disciplines, and physical and social science, and in case of business and humanities and different kind of manufacturings and government, every sector we are going to be using the statistics. Okay, and even individual also can use the statistics to make the decisions, right? For example, uh, you are just talk about ourselves actually. So for example, in a monthly I'm earning, for example, $10,000. Okay, so that is my income, right? Okay, so in a meanwhile I may do some kind of expenditure, right? Like maybe rent, and some kind of groceries, okay, and travelings, okay, some kind of unexpected things, right? This all things we have it some kind of information, right? Expenditure and our income. So in every month I can compare, right? Okay, after I compare, then I can conclude that maybe in the next 2 years, if I want to earn this amount, so whatever the earnings right now I'm doing, it is not sufficient, right? If you don't know that, if you're not doing that kind of statistics in your home, you don't know what exactly in future what you want to do it, right? So that's the reason even individual also can do some kind of statistics about for doing some kind of planning and budgeting. Okay, and to organize that particular family in a proper way. Okay, so make sure that statistics will help you individual as well. Okay, even banking also uses the statistics. Okay, lower risk in lending operations and analyzing activity in the financial market and predict the impact of economic crisis. This all things we will do with help of the statistics only. Clear? That's a this is the way we are going to be using the statistics. And just analyze yourself. I'm just giving you 1 minute of time if you have any kind of questions.
Are you speaking, Anjan? We can't hear you. I can't hear you.
sorry, it's my fault. Okay. Yep. I have a small questions. Can you answer these particular questions? Jagdish, can you answer it?
Yes, sir.
What is statistics, Jagdish?
We can analyze with statistics, sir,
Hmm.
in three methods.
Okay, fine. So we'll talk about a type of statistics. Okay, there are two types of statistics we have it. Okay, the first one is it's a descriptive statistics. What is descriptive statistics? Previously, I already spoke with you, right? Analytics we can do with a descriptive or a prescriptive and a predictive, right? So when you go for some kind of descriptive statistics and descriptive analytics, make sure that we should go for using the descriptive statistics only. Okay, descriptive statistics, it might be included different kind of measure of central tendency, measure of variations, and some kind of graphs. Okay, and a little bit of probability things, which is comes under the descriptive statistics. Okay, the second type of statistics is it's inferential statistics. So inferential statistics, what exactly inferential statistics? Inferential statistics, previously we'll talk about, we already spoken about prescriptive statistics and predictive prescriptive analytics and predictive analytics, right? That predictive and prescriptive analytics we will do with help of the inferential statistics. In case of inferential statistics, what exactly we will do here, it allows to the make the predictions and from the data. With inferential statistics, you can take the data from the samples and make the generalization about the population. So when we have some kind of population and when we have some kind of sample, you can, okay, so you can so give some kind of whether your population, whether it is a replica of your population, whether your sample whether it is a replica of your population or not, that we can able to easily do it with help of the inferential statistics. And there we can do some kind of hypothesis testings like chi-square test, ANOVA test, or else a z test, a t test, different kind of hypothesis test we have it. With help of those things, we can compare your population and sample, both are same or different. Okay, so this is the way we have two types of statistics. We have it descriptive statistics and inferential statistics. And when it comes to the descriptive statistics, it will help you to describe about your data in a charts or graphs and tabular formats. Clear? Is this clear? Can you please note this
Yes, sir.
information?
So this basic definitions, right? Just to get a uh, grasp of this, do you have any? Can you link to any specific website just to get the definitions part of it, or just Google it? I think you're on mute again.
Okay. Stratology is another one of the website. Okay, So usually they will talk about, statistics only. Okay. Okay. When if you want to go ahead with that one, statology.org, even the basic stats. No, here we have the introduction to statistics, right? Okay, population, sample, statistics, parameter, okay, and measure of levels of measure of this is the data we can compare actually. So even this is a good explanation, okay, when you want to practice yourself and visualization things and lot of probabilities, okay, and random variables and some confidential intervals and hypothesis test. Here we have a t-test, z-test, right? And so p-value, effective of the p-value, and chi-square test, and do some kind of regression things, and ANOVA test. This all comes under the statistics only. Especially from this particular statistics, who wanna become like a data scientist, okay, it will help a lot. Clear, right? So even if you want to go ahead with
Yeah.
this area, well, definitely we'll talk about this one. Okay, so here the first statement, what exactly we are talking about actually. So it's a why the statistics is important. There are 10 reasons they're explained in a better way. Okay, the field of statistics comes in collecting, okay, of course it's collecting, analyzing, and interpreting and presenting the data. So this is exactly the statistics is doing. What are the 4 steps? Collecting, analyzing, interpreting, and presenting the data based on what? Based on the problem statement, right? As the technology becomes more present in our daily lives, more data is being generated and collecting now than ever before in the human history. Okay, because of because of this social media, okay, so the data is collected in a terabytes format. Okay, data is not in a small, it's a large. Okay, data is sufficient. Last decades back, data is very expensive. For getting the data is very expensive, right? Because of no data, right? If you don't have a data, then demand will be more, right? But because of this social media, data cost is now less, so that most of the companies are comes to do this particular operations. Okay, so statistics is a field that can help you understand how to use this data to the following things. So there is a 3 things are there to help you to understand this particular, gain a better understanding of the world around us, and make the decision using the data, and make the predictions about the future using the data. So one is the decision using the data, make the decisions, and we can do the predictions as well, and we can better understand. Better understanding means it's analyzing, understanding the data. This we can say it's a description. Okay, and this is prescription, this is predictions. Just one second. Okay, so with the help of statistics, what we can do, we can do these 3 things actually. One is understanding the data, second one is making the decisions, and third one is predictions actually. These 3 things we can do. Okay, right? And so the heading, what it is explaining actually, the importance of the statistics, right? There is a 10 importance we have it. The importance of one, use descriptive statistics to understand the world, right? So here descriptive statistics is used to describe chunk of raw data. There are 3 main type of descriptive statistics. One is summary statistics, and charts and tables, right? So with help of these 3 ways, we can descriptive about your data actually. Even the data is a raw data, but we can describe charts wise or tabular formats, and with help of some kind of summary statistics. Clear? Are you following?
Yes, sir.
Okay, so even this website can be accessible everyone, so you can go ahead actually. So that's the best right explanation. Even you don't need to follow multiple, you don't need to go ahead, different other websites. This is the website is good for us. Okay.
Yeah, I agree. I think this is a good one. I think this is a good structure
Yes,
which you
even they
told. Yeah.
explain in a better way, and even they have a lot of coding part also. Okay, so even if you go ahead with so some kind of codings also could be there. Okay, you don't need to worry about it. So just try to understood, and if even by the time of learning, if you are getting any kind of doubt, definitely I will explain you. Okay, even sometimes I can follow this one. So each of this, it can help you better understanding existing data. For example, there is some example. Suppose we have a set of raw data that shows our test score of the 10,000 student in certain city. Okay, so we have a 10,000 students. This is one city information, right? Suppose we have set of raw data that shows the test score of 10,000 students in a certain city. Can we use a descriptive statistics, calculate the average test score and standard deviation test score, and generate the histogram and blocks plot? This is descriptive statistics, displaying the histograms, displaying the box plots. You might be thinking what is box plot and what is histogram, right? Nothing much actually. Box plot will help you whatever the data we have it, that it can be showing in a 5 elements in a graphical format. Okay, 5 summary data. And histogram in the sense the distribution we can see in a graphical format, the frequency distribution. Okay, so we can calculate the average test score and the standard deviation of test score. Okay, and this is one question. So here we can use descriptive statistics to calculate the average, standard deviation, and plotting some kind of graphs, and create the frequency table to understand the distribution test score. Okay, and using descriptive statistics we can understand the test score of the students, how much they're easily compared to the sharing the raw data actually. Okay, when we have a data, so it's very tough, right, to understand but when we go for the different kind of descriptive statistics, now we can easily understood. Okay, and the second reason is to be wary of misleading charts. Okay, so misleading charts in the sense, you just see this one, college admissions. Some students are attending the college very less, right? Okay, I mean the college admission. Some colleges it might having the higher admission. Some colleges it's having the medium admissions. Some colleges having the low admission, right? See, even we can do that kind of where so there are more charts being generated in journals, news outlets, online articles, and magazines and over before. Unfortunately, stats can often misleading if you don't understand the underlying the data. Okay, so even here here if I plot it, but we can't understand in a one single word, right? So so sometimes you might be getting the misleading. Even we can provide the graphs. Okay, but that graph it cannot be understood in the proper way, but by the time we can explain in a good way actually. So here GPA and ACT, if both are low, then college admissions are less. Okay, and GPA and ACT could be the more. ACT means it's some score actually. Okay, low GPA and low are not get admitted. See, for example, if these two scores, if I'm not doing this line, this middle two lines, it's very tough to understood, right? And which area we are getting the less admissions and which area we are getting the high admissions, right? See, the graphs will to help you. This descriptive statistics will help you to understand the better way actually. Okay, be wary of confounding variables and okay, starting weight and independent variables and dependent variables. See, the unlikely, there are likely clauses, the confidence variable temperature, where the warmer outside, more people buy ice cream, and more people go in the ocean, right? See, affect the relationship between these two variables, and to make the better decision using probabilities, and to understand the p-value in research. Okay, this everything we'll talk about in our future classes actually. To understand the correlation, what exactly the correlation means, it just giving the relationship between how much, what's the strongness, what's the strongly associated with the true variables, how strongly they are associated with the two variables, that we can talk with the help of the correlation. Covariance means what could be the relationship between these two variables, that is the covariance. Okay, and make the predictions about futures. with help of different kind of machine learning algorithms. Okay, and so to understand the potential bias in a studies, and to understand the assumptions made by the statistical test. Okay, and to avoid the overgeneralization. See different population and sample, right? See, you just observe here we have a population, and there is two elements are there, this pink color and somewhat blue color, right? So the data which is here this data is equal, and here this data is equal, right? But this is the population data when I am compare with the sample, but this pink data which is representing this and thing, that means this is two or not represent, this is sample is not representing our population, right? Because of your blue color layers and pink color layers are approximately same, but when it comes to the sample, the pink color layers are very less when compared to the blue color, right? So that means this is a population which is not replicating your, sorry, the sample is not replicating your population, right? So that kind of things we can do with help of the statistics only, avoiding the overgeneralization, right? So this is the way, these are the most 10 importance of statistics. Okay, and you can go ahead learn, that's a very simple thing. And now we'll talk about descriptive and inferential statistics, right? I think we are in that part only. Okay, let's talk about this one. Basically there are two branches are, I mean there are two types of statistics are there. People can call it the descriptive statistics, and people can call it the inferential statistics, right? So when it comes to the descriptive statistics, okay, so you already know that if you want to describe your data in a popular charts or graphs or tabular format, then we can able to go ahead with the descriptive statistics, right? Okay, common form of a description form of descriptive statistics, one is the summary statistics. So this summary statistics, we have a two types of statistics are there, measure of central tendency and measure of dispersion. So that means whenever you have some data, so that from that particular data we have to give some kind of summary. So what kind of summary? That means what is central located point and what is the variation is there, that two things we are talking, right? So that's the reason we have a two type of summary statistics. One is the measure of central tendency, second one is measure of dispersion. Okay, measure of central tendency, which is purely talk about your central point. The number describes where the central of data set is located. For example, your mean, median, mode, that kind of things we can call it as the measure of central tendency. Even these things we will definitely talk about in future classes. Okay, measure of dispersion means the data is variated, right? The data is can be spread, right? Okay, the data is not like in one element or two elements, it may be the data is huge, right? 10,000 students information, that means the data is very huge. When the data is, okay, when the data is huge, that particular situation we can able to go for describe how that particular data is spread out in the data set. That we can talk with different examples, which are range, interquartile, standard deviation, variance. This is the methods, these are the methods which help you how the data is distributed and how the data is spread around the central tendency or central value, right? That is exactly we are calling it say measure of dispersion. This is the two things we'll call or which comes under the part of the summary statistics. Okay, the second type of descriptive statistics is graphs. That means we can visualize your data in a different graphical format, which are box plot, histogram, stem and leaf plots and scatter plot. With help of this particular graphs we can able to describe the data in a visualization format. Okay, and whatever the data we have it, that particular data we can able to understand in a tabular format. Okay, tables can help you to understand how the data is distributed, and one common type of table is frequency table. Okay, what exactly which is staying actually, which tell us how the data values are falls within certain ranges. Okay, so with help of tabular tables we can understand the data, with help of the graphs also we can describe the data, and with help of the summary statistics also we can describe the data. This is the three types, or this is the three ways we can able to go for describe your data with help of the descriptive statistics. Any questions regarding about this one? Guys, this is the three ways only we can do the description about your data with help of the descriptive statistics, or else this is the three ways we can do the descriptive statistics. Any questions?
Tables is a mechanism for actually collecting the data, right? That's how you collect the data. Then you summarize and then draw graphs out of tables. But I think in this, the only thing that's kind of I'm finding a little weird is tables, graphs, and summary. I mean, tables is basically the storage of the
No,
data that you're
no,
collecting, right?
not like that actually. So just give me 1 second. For example, you have a 10 thousands of data we have it, right? Okay. So for example, the age group people are in between 25 to 30. Okay. Okay, this range of people might be they are getting the some test score, right? Okay, so even 25 age group people, 30 age group people, or 50 age group people, everybody having the with some ages wise, right? But it's a 10 thousands of records are there. Okay, so it's very tough to understand each and every value, right? By the time this is the same data, what I can do, I can make it some kind of tabular format. How tabular format in the sense, for example, age, in the age in between 25 to 30. Okay, so the test score is around 500 to 600. Okay, for example, 18 to 24, maybe 500 to 800, this range. See, even you have it 10 thousands of records are there, that particular 10 thousands of records we
Okay, okay.
are
So
able
you're
to go
saying
for the
basically, as you collect the data, putting it into a tabular
tabular
format is
format.
also kind of descriptive
Description, that's
analytics.
correct.
Okay,
That's
okay,
correct. That's
got it.
correct. Whatever the data we have it, that particular table, even the data, it was in the format of tabular format. Because of the data, it might be comes from the databases. The data, it might be comes from the Excel formats or CSV format or data frame formats, right? Everywhere the data is a tabular format only. But the tabular format, it's a huge data. That huge data, it's a very tough to understand. So that we can compress that particular tabular format, tabular data into the compressed table. Okay, the compressed table, it's your understanding how we are going to be compressing and to understand by the stockholders, right? So that we can do it. So even the data we can representing with a tabular format, that is also it's a
Yeah, yeah, I think I got
descriptive
it. I
statistic.
think even the pivot tables in Excel is pretty much a
Yeah.
tabular analytics, right?
Yes,
Yeah,
absolutely
okay.
correct. Even from that one, this is the example frequency table. Frequency table in the sense, for example, uh, let's do a small example. Okay, so yep, every day you're buying some, groceries, right? Okay, week one you're buying the type of grocery type 1. Okay, week 2 grocery type 3, again week, and a day 3 again grocery type 1 you're buying, right? So this particular situation in a same week, two days same grocery type is repeated, right? So there is a 5 records are there within, instead of using the 5 records, what you make it actually, so grocery type 1 which is repeated 2 times, grocery type 2 it is repeated only 1 time, grocery type 3 which is repeated only 1 time, grocery type 4 which is repeated 2 times. Now the 6 done, right? One day some grocery type 4. So there are data, it was in a tabular format, but it is the raw data. That particular raw data we are making into the frequency format. Same grocery type which is repeated in a month 5 times, grocery type 2 which is repeated 6 times, grocery type 3 which is repeated 15 times. Okay,
Yeah,
so
yeah.
this is the way you're shorting that particular short, we are shorting that particular table into smaller format actually with the help of the
Yeah, I think
frequency table.
you use the right term. The raw data tables are
Yes,
essentially you can't assign much of a meaning to
yes,
that, but
yes,
once
yes,
you're as an output a table is being created, that's
yes.
what the
That's
analysis is.
correct.
Okay.
That's correct. That's correct. Even just to understand the data, we can go ahead with some kind of frequency table. With the help of the frequency table, we can understand how frequently one particular thing which is repeated in the particular time. Okay. So different kind of examples here. The following examples. How might we descriptive statistics in the, suppose 1,000 students in certain school. Okay, all take the same test. So one particular test, they're attending the 1,000 student. We are interested to understand the distribution of the test score. So we can use the following descriptive statistics. Okay, so what could be the average score of that particular 10,000 students? That is the summary statistics. What is the median value of one particular person? Okay, what could be the max and minimum values? That is also summary statistics only. Okay, so this is a measure of dispersion, min max. Okay, min and max is the in between this two score only the data is distributed, right? So this is measure of dispersion. This mean and median are the measure of central tendency. Okay, so in a graphical formats, right? So histogram, so this is the test score. So even below 50, this many people are got. In between the 50 to 55, this many students are got. Okay, so this is the frequency of the students. So total we have a 10,000 student, 1,000 student, right? This 1,000 student, they are distributed with the test score format. So this is the graphical format we are representing. This kind of graph we are calling it histogram.
Yeah.
So same thing we can do in a tabular format.
Yeah, so I think I'm getting a sense. So when you create a dashboard in Tableau, for example, you kind of
Yes.
in a descriptive analytics, you create
Yeah.
all three. There is a summary
Yes.
that you present, and
Summary.
then you have the
Yes.
graphs as well as
Summary,
the tables.
visualization,
Okay,
tablers. This is the three ways we can describe the data.
got it.
Okay, now the second type of thing we have it. Second type of statistics is it could be no inferential statistics, right? Inferential statistics use a small sample of data to draw an inference about your larger population. Basically, population is very large. When you're working with larger data, you might need to be do a lot of resources, right? Your RAM, and it's very tough to make it lot of things. Okay, by the time what we can do, we can take the small sample and we can influence about your larger population. Okay, inferential statistics uses small sample of data to draw the inference about a large population that the sample come from. See see you are taking the samples from this particular population only, but this particular sample, whether it is replica of your population or not, that we can do with help of the inferential statistics. Okay, there we have some example. You might be interested to understand the political preferences of million of people in a country, right? So is it possible to go and do the survey each and every person? It's impossible. In India there are 150 crores of people out there, right? Out of that one, there are more than 18 age group people, around 70 to 80 crores of people, right? It's impossible to go and do the survey for this 70 crores of people, right or not? By the time what we can do, we can take some kind of sample data, or we can go for one particular area, and we are picking some people and taking some kind of survey, and we are going for another area and taking some information instead of going for entire city people. Okay, so you're visiting each and every city and taking some samples from each and every city, and we are combining that all, and we are replicating your entire country population, right? Yes or no? So that we will do with help of the inferential statistics only. Okay, this is important. So the importance of the representative of sample in order to confident in our ability to use the sample of the draw the preference about our population. For example, if you don't have, so when you want to do some kind of analytics in future with help of your sample data, okay, if you're not confident about your sample which is replicating of your population, can we use it? Can we use it? If you're not confident about your sample data which is replicating of your population, can we use in your future data as that?
No, sir.
No, right? So first of all, you should be confident about your sample whether it is representing your population or not. Okay, so we need to do some kind of testings actually. So of course we can do some kind of sampling techniques for taking the samples from the population. But whether your population or whether your sample data, whether it is replicating or not, that definitely will talk about inferential statistics. Okay, so there are different kind of sampling methods we have it to draw the sample data from the population. So there are simple random sample, symmetric random sample, cluster random sample, stratified random sample. This random sampling techniques we will definitely talk in a future classes. But with help of this particular sampling techniques, you can replicate your you can make the sample data from the population. Clear? Clear or not? Make sure that your sample size is large enough. It's not like five elements or six elements. It should be large enough, but not exactly not equal to the population. Okay, along with using approximated sampling method, it's important to ensure that the sample is large enough so that we can have enough data to generalizing your larger population. Determine how large your sample should be. You should you have to consider the population side and you're studying the confidence level you would like to use it, and the margin of error, it could be acceptable actually, okay, like plus or minus 2, that kind of things. The common form of inferential statistics are hypothesis tests. I'm always using this terminologies because of with help of these things only we will able to do your sample is replicating your population or not. After your entrance transfer question about your population, in the percentage of the people who supported candidate higher than the 50%, right, the mean height of certain plant equal to the 14 inches is the difference between the mean weight of the students at a school A compared to the school B. So this all things confidence intervals. So this confidence intervals also, it's a inferential statistics only. Confidence intervals in the sense the giving some kind of range of things, okay. So you might produce 95% you confident about your data which is for in between these two things. That is exactly confident interval is doing. It is giving the two intervals, lower and upper, okay. So with some percentage, if I said 99% of the confidence interval, that means 19% the data it is fall in between these two in this particular area. We can say that 95% confident that the true mean weight of the plant species between these two ranges, to these two intervals. Even regression is also inferential statistics, okay. See, descriptive statistics which is giving the summarization, inferential statistics which is giving some kind of use the samples to draw the inference about your larger population. Clear, right? So that's for today's session, guys. And so tomorrow what we can do, and I would like to go for, as this is the website is fair enough, I would like to go for using this kind of content because of I don't want to deviate you, okay. You can go ahead and work with this particular data, I mean this website, okay. So these two things we can learn for this particular class. So tomorrow, and we will talk tomorrow also, we have a session at the same time, population and sample statistics and parameter. And if we have the time consist, then we'll talk about these 4 topics under the introductions to statistics. Even you if you have interested, if you want to learn yourself and go on to do this particular document, and definitely if you are getting any doubts, I will help you, okay. But don't
Yeah, actually,
Hmm.
I have a something going on tomorrow at 10:30 and 11:30.
Yeah, yeah,
So
you can go ahead
I
this
won't be able to
yeah,
attend.
yeah, no problem, no problem.
Maybe I'll attend 30 minutes first, but
Yes, sure, sure.
11 I have to leave.
Yeah,
Okay.
okay, good enough. And usually we have a session, Python session also we have it, don't forget about it.
Yeah.
So what I'm trying to tell you actually, so you have a parallel session, statistics and Python. And so if you're interested for machine learning, I want to take the machine learning after the Python classes, if the time consisted. If you don't need it,
Yeah.
then you can
No,
attend.
I need it. I need to attend that.
Okay, so yeah, you can come for Python session. We'll talk in a Python session again, okay.
Yeah.
Yeah, bye, take care.